Namaskar, hello everyone and welcome to my YouTube channel. Okay, so we talk about digital India. Do you understand the term digital? Today we will be talking about digital signal processing. So this is an area of science and engineering which has been developed due to advancement in digital computer technology and integrated circuit fabrication. So why at all are we talking about this? Let's talk about the history. Now, the digital computers and the related hardware were very large and expensive, and in order to find the solution, we'll always struggle. Struggle leads to inventions. And the result was the development in integrated circuit technology, from the medium scale integration to the large scale and then to very large scale integration of electronic circuits. So what do I mean by integration of electronic circuits? It is the process of integration or embedding these many transistors which are resulting in these many logic gates for the respective scales of integration on a single silicon chip. So all this led to the development of digital computers and associated special purpose digital hardware that are powerful, smaller, cheaper and faster. So we are basically talking about signal processing, and two terms you must be knowing. One is digital, one is analog. Why not carry it by analog means? Like, why not analog signal processing? Reason being, when we talk about analog signal processing, it is too difficult and too expensive. So all this discussion leads to various advantages of digital signal processing, and let us compare in what areas or in what fields digital signal processing is better as compared to the analog signal processing. So digital signal processing is always more reliable. Also allows programmable operations. Like through software, one can easily modify the signal processing functions that are to be performed by the hardware. Because of this, we can obtain greater flexibility in system design, higher order of precision using digital signal processing. In digital processing, an analog signal has to be converted to a digital signal. So before coming to the drawbacks that this process leads to, let us first talk about the steps that are required to convert an analog signal to a digital signal. First one being sampling of the analog signal. And the second step is quantization. We will be talking about these terms in detail later on in the video. So this results in distortion of the analog signal, that is, the actual signal, and makes it really difficult to reconstruct the analog signal from the quantized samples. So what do we do next? We have to control or limit this distortion. And how we can do this? First of all, we can choose proper sampling rate, proper choice of the sampling rate. And second one is that we can increase the precision in the quantization process. Two steps were there and we have improved both of them, which will always lead to better results. Now we are talking about this huge topic called digital signal processing, and I'm sure that most of you don't even know what actually do we mean by the terms digital, signal and processing. What to talk of digital signal processing? First of all, let us take up the term signal. What is a signal? Now signal is a physical quantity that varies with space, time or any other independent variable or variables. That means mathematically you can represent a signal as a function of one or more independent variables. So these are the representations. If your signal is a function of one variable only, that is time, and in the second example you can see the signal is the function of two variables in space, the x and the y coordinates. So these two signals were easy to understand, but however the functional relationship can be complicated, which is the actual situation that we face. This functional relation to represent a signal can be complicated. For example, we talk about a speech signal which can be expressed as summation of various sinusoidal signals. And to represent a signal, we know that we need three parameters: the amplitude, frequency and phase. These three parameters, if these are known to you, you can easily represent your signal. And a speech signal is summation of a finite number of such sinusoidal signals, where the amplitude, frequency and phases, each of the three parameters, they are varying with time. So talking about signals, another example can be ECG, the electrocardiogram. Now this particular signal provides doctors with information regarding the patient's heart. Another example is EEG, electroencephalogram, which provides information about the activity of human brain. So speech, ECG and EEG are the examples of signals which involve the variation with time, which are evolving with the time. Now I also discussed that signals can also vary with space. An example of such a signal is an image signal, which is a function of two coordinates, x and y, these spatial coordinates. Now if this is clear, it is also important to know about signal generation, how the signals are actually generated, from where a particular thing is coming, the origin of that particular thing needs to be known. We are talking about signals, let us talk about signal generation. Starting with the generation of natural signals, when we talk about speech, like I'm talking, what am I doing? I'm forcing air through my vocal cords, which leads to the generation of a speech signal. And generation of image signal, what do we do there? We expose a photographic film to a scene or an object. That is how we get an image signal. That means the generation of your signal is ultimately associated to some sort of a system, and it is this system that responds to some stimulus or force. So in case of a speech signal, the system comprises of the vocal cords or the vocal tract. Now this stimulus in combination with the system is what we call the signal source. Now let us move on to system. What is a system? It is a physical device that performs an operation on the signal. Signal का क्या करना है? Signal पे कौन सा operation लगाना है? It is what the system is doing. For example, a filter is a system which is used to reduce noise and interference from the information bearing analog signal. कुछ टास्क किया, उसने नॉइज और इंटरफेरेंस को एक इंफॉर्मेशन बियरिंग सिग्नल से निकाल दिया. दैट मीन्स इट हैज परफॉर्म्ड सम ऑपरेशन. सो सिस्टम in that case is your filter. So what is signal processing? When we pass a signal through a system, we say that we have processed the signal, because some operation has been performed on that signal, and when such a thing has occurred, we say that the signal has been processed. So that means filtering of noise and interference from an information bearing analog signal is what is signal processing. We say that we have processed the signal. Now system, I told you that it is something that performs an operation on the signal. Now the type of the system. The type of the system will now automatically be based on the type of operation that it performs on the signal. So there can be linear operations or non-linear operations, and likewise the systems can be linear or non-linear. A system is said to be linear if it obeys the principle of homogeneity and principle of superposition. The principle of homogeneity says that a system which generates an output yt for an input xt must produce an output a times yt for an input a times xt. According to the principle of superposition, a system which gives an output y1t for an input x1t and an output y2t for an input x2t must produce an output y1t plus y2t for an input x1t plus x2t. A system is said to be non-linear system if it does not obey the principle of homogeneity and the principle of superposition. So that means our system includes the physical devices, hardware, and the software wherein the operations to be performed on a signal can be realized in that software. System comprises of both the software as well as the hardware. Operations performed on a signal consist of a number of mathematical operations as specified by the software program. Now what is this program? This is the implementation of this system in software. सिग्नल पे अगर आप operations realize करवाना चाहते हैं सॉफ्टवेयर में, you will be using programs. Operations अगर आप सिग्नल पे realize करवाना चाहते हैं using software, you need programs. So there are sequence of mathematical operations through which the system can be realized on a digital computer. Another term that I would like to discuss over here is algorithm. This is the method or set of rules for implementing the system by a program that performs the corresponding mathematical operations. So there can be a number of algorithms to perform a specific operation. It's not unique, there can be number of such algorithms, and out of all those algorithms, what are the qualities of a good algorithm? These are: your algorithm should be computationally efficient, fast, and can be easily implemented. Efficient algorithms are required for performing such operations like spectral analysis, filtering, or correlation, etc. So this is how digital signal processing system is realized in software. So that means your digital computer can be programmed to perform digital filtering. So this was about how we can use software to realize the digital signal processing. However, this digital signal processing can also be realized through digital hardware like logic circuits, which are configured to perform the desired specified operations. So that means that digital system is a combination of digital hardware and software which perform their own set of specified operations. So this means that processing of a signal by digital means can be done either in software or hardware. But the thing is that most of the signals that we come across are analog signals, and for this reason we need to know analog to digital conversion for processing the signal. So that was all for today. I hope you liked this video and it was informative, and I recently created an Instagram account. You can follow me there as well. I'm not a very social person, so I recently created an Instagram account just to promote my channel so that I can reach out to more people. Do follow me there as well, and I'll be back with my next video. Till that time, you do not forget to take really good care of yourselves.